Time. A thing we all experience. Every day, we see time move forward at the same pace, never slowing or stopping.
All of our clocks move forward in time, and that's simply accepted as a fact.
However, our perception doesn't see what's really happening with the space and time around us.
Your local frame that you're sitting in, your clocks work just fine. You can't tell anything's wrong or different or strange. Now, they might not agree with somebody else's clock who's someplace else.
We don't realize that we live in a world where forces in space can drastically change the flow of time.
There are also ways to slow time down by actually slowing down the laws of physics.
Enter a universe. A moving universe where gravity and speed distort time itself. Where one person's perception of time can drastically differ from others. And where rules and regulations control the very universe itself. This isn't science fiction. This is the universe of relativity.
The perception is that time, clicks along at irregular intervals, at regular time periods. But in physics and astronomy, we learned that time is relative. And we see that time actually can be perceived differently by different observers traveling at different speeds relative to each other.
The reason time moves differently is because of a postulate that Einstein proposed in order to explain problems we were having making measurements, right? There was a problem in the turn of the last century with understanding electricity and magnetism and what happens at high speeds.
In Einstein's special theory of relativity, he showed in 1905 that objects that travel at high speeds will have the laws of physics slowed down for them so that time slows down.
A clock that is moving quickly will slow down relative to a clock at rest, say a clock in this room. The faster the clock is moving, the more it slows down. And as it approaches the speed of light, then we would see that clock ticking more and more slowly as it got closer and closer to the speed of light. And eventually, the clock would not be ticking at all. It would be ticking only so slowly you might not notice it.
You can even do time travel by slowing time down. You can travel into the future. And that may sound a little strange, but the idea would be that if I slow time down for myself and time clips along at a regular rate for everyone else, then maybe one day goes by for me, maybe 10 years go by for you. When I'm brought back into the regular time, I've effectively traveled 10 years into the future.
But time travel into the future isn't enough for most people. For centuries, people have dreamed about going backwards in time. Perhaps to correct the mistakes of the past, or to simply observe the greatest moments in human history. So, if moving at the speed of light can slow down or stop time, would going faster than light be enough to reverse it?
Strictly speaking, according to Einstein's theories, you can never travel faster than the speed of light. You can never reach the speed of light if you're a finite, massive thing, like a person in a spaceship.
Einstein says that for objects or people that travel near the speed of light, the mass of the spacecraft gets heavier and heavier and heavier and becomes infinite as you approach the speed of light. So you would need more fuel than there is mass in the universe to approach the speed of light. So of course you could never have so much fuel.
So you could certainly have time be very different between you and a different observer, but no, you won't go back in time.
We also see that time clips along differently or slows down for those who are in a strong gravitational field as compared to others that are not.
For example, here on Earth, in the gravitational field of the Earth, our clocks are ticking ever so slightly slower than clocks in orbit way up, far out by, say, the moon. In fact, the GPS system that you use to locate yourself on the Earth, that system had to take into account the change in the clock rates when they launched it from the Earth into high orbit.
The gravitational field of the Earth goes down as the altitude goes up. And so a clock that's at a higher altitude is further away from the center of the Earth, and the gravitation is less there, and the clock will in fact tick slightly more slowly.
We can measure the effect here on the Earth with just the Earth's gravitational field, which is very weak. So you can imagine what it's like if you get close to a very compact object like a neutron star or near a black hole.
A black hole is a star that has lived out its life and died and then collapsed. Now, if the star was a very massive star, when it runs out of fuel and dies, it doesn't just die a quiet death. It explodes in a spectacular supernova. And if the remaining mass is greater than 3 times the mass of our sun, then the gravity from that star will crush the star down to a point infinitely smaller than the head of a pin. We call that a black hole. And it's called a black hole because the light trying to escape from this, it's very bright, in fact, but the light trying to escape, as it flies out into space, the gravity pulls back on it and it collapses back down in on the star. So the light itself cannot escape.
Black holes are an extreme example of very high gravitational fields, and so clocks can run dramatically differently in a very strong gravitational field.
If you were to drop a clock into a black hole, as it approached the surface of the black hole, you would see the clock ticking more and more slowly, but you would never see that clock start to go backwards.
As you fall into a black hole, relative to someone on the outside watching you do this, time slows down, right? And time slows down more so and more so until at the event horizon time would stop. But for you falling in, you don't notice the time is slowing down because all the laws of physics slow down, your biochemical reactions slow down, the impulses, the electrical impulses in your brain slow down, so that you're thinking slower, so you don't even notice the time has slowed down.
Though we may never truly understand black holes, it becomes clear that it is impossible to go back in time in our universe. But what if we left our own universe entirely? What if there was a way to both leave our universe and arrive at a parallel one at a different time? Wouldn't that be a form of time travel?
You could imagine that there is something that is not a black hole, but that is a kind of a hole in space of a different sort, where if you were to fall into it, you would come out or pop out at another location in the same universe or a different one. And those are called wormholes.
We don't even know if wormholes exist. We know black holes exist. We have no idea if wormholes exist.
What you have to do in order to make a wormhole is have access to some kind of matter that doesn't exist in the universe we have. It would be matter that has a kind of negative mass. We don't really understand quite why, but the universe we live in prohibits that kind of matter from existing as far as we know. And the result is that you could not actually make a wormhole in our universe.
But even if we were able to surmount the incredible task of going back in time, there is still an additional factor to consider. Our universe exists as both time and space, and as such, our navigational concerns are not restricted to time alone.
If I had a time machine and I went into the time machine and I went back in time, there's no way that I would be at the same location on the Earth, because the Earth is moving.
The Earth, right now, everything is in motion. Right now, we are rotating around the Earth once per day. We're moving 800 to 1,000 miles an hour to make it around the Earth in one day. The Earth itself is traveling 65,000 miles an hour to make it around the center of our solar system, the Sun. The whole solar system is traveling 500,000 miles an hour to make it around the center of the Milky Way galaxy within 250 million years.
So if I had a little dial that could make me take me back 10 years, where would that take me to in space?
I would come out somewhere else in our universe between the stars in vacuum and die.
Time can change, but why? And it's difficult to give a satisfying answer. The universe behaves kind of how it behaves. And some of the things seem to make sense to us, and some of the stuff doesn't make so much sense to us.